This next part goes over something that we already went over when we looked at the unit circle. It says the quadrant signs for the sine, cosine, and tangent functions are shown in the figure below. To extend the use of trigonometric values of common angles, tables, and angles in quadrants other than the first quadrant, you can use the concept of a reference angle. So what are we talking about with a reference angle? Let me draw a picture to show you what a reference angle is. Imagine if we wanted to find, I'm going to draw an angle like this. Here's my angle, and I called this angle theta right here. If that angle right there is theta, let me erase a little bit to clear it up. So if that angle right there is theta, the question is, what would, for instance, cosine of theta be? Well, the issue is theta doesn't create us a right triangle. We can't drop it and make a right triangle at all. But what I can do is create this triangle right here, closest to the x-axis. Always drop a vertical line down to the x-axis. If I called this the point xy, okay, I would know this would be a negative x because it's to the left. It's a negative x value. This would be a y, right? Then you would have your r value. If you're using the unit circle, that's always 1, which is really nice. But what's the idea? I'm going to call this angle phi right here. Let me use the other Greek letter instead of theta. I'll use phi. And the idea is this red triangle is called a reference triangle. And this red angle phi is the reference angle to theta. And the beautiful thing here is that the cosine of theta is the exact same thing as the cosine of phi. In other words, all you have to do is draw that triangle and use that triangle instead, just noting that all of your x values are negative here. So that's what a reference angle is, and a reference triangle is saying, look, if you want to find the trig values of theta, just find the trig values of phi instead. Again, I'm not teaching you trig here, I'm just reminding you of what it was. So they give you some examples. If you wanted to find the sine of 3 pi over 4, you could find the exact same thing as the sine of pi over 4. Why could you do that? Well, 3 pi over 4 would be in the second quadrant, pi over 4 is in the first quadrant, and we know they're exactly the same because they're actually not exactly the same. There is something messed up here. Sine of 3 pi over 4 and sine of pi over 4, no, they are the same, because this sine is the y value, and if you think about the y value of 3 pi over 4, that's in the second quadrant. Your y values are positive, and this is again the y value. If you think about the y value in pi over 4, that's in the first quadrant. It's also positive, so both of those values would be positive. But if you want to do something like sine of, I don't know, how about 5 pi over 4? It's going to be the same value as 3 pi over 4 and pi over 4, okay? Except you got to be careful here because this is in the third quadrant, and in the third quadrant, their sign values are negative. So it would still be a root 2 over 2. It would just be a negative value instead, okay? That's what they noticed in the next one when they said tangent of 330 degrees. If you know where's 330 degrees, well, I know 180 is exactly halfway, right? Plus 90, so straight down is 270. So 330 would have to be in that fourth quadrant. Tangent in the first quadrant we know is positive. Tangent in the fourth quadrant we know is negative. So it's the exact same value, the root 3 over 3, we just know that it's negative. So in other words, evaluate all your values in the first quadrant and then just do the appropriate positives and negatives based on the quadrant it is. And this chart tells you what are each of the values of sine, cosine, and tangent. We already worked through this. When we worked through this, we showed exactly what it was. Remember, if you know sine is positive, you know cosecant is positive. If you know cosine is positive, you know secant is positive. And if you know tangent is positive, then you know cotangent is positive because those are just the reciprocals. So what they know on what they put is they put the ASTC, okay, or SATC. It depends on how you want to read it, okay. But I look at it as ASTC, doing the proper things in the proper order. Quadrant 1, 2, 3, 4. What they're telling you is which ones are positive in there. So in quadrant 1, A stands for all are positive. In quadrant 2, it says S because sine is the only positive one. In quadrant 3, it says T because tangent is the only positive one. And in quadrant 4, it says C because cosine is the only positive one. Okay? So it's just showing you the reference angle. To find the reference angle, well, if it's in the first quadrant, there is no reference angle, just drop your line and make your triangle. If it's in the second quadrant, you drop it down vertically to the x-axis. Third quadrant, always drop it vertically to the x-axis. Fourth quadrant, always drop it vertically to the x-axis. Never make that triangle to the y-axis. Always make it the triangle, the reference angle, with the x-axis. It shows you how do you find the measure of that reference angle. Well, if you notice, for instance, let me show you right here. Look at the quadrant. In quadrant 2, let's think about it. If this is angle theta, the entire thing has to be 180 degrees. So how do I find the remaining part? Well, I would do 180 minus theta would give me the measure of the angle. That's in degree form. It would be pi minus theta if it was in radian form. If you think about this, in the third quadrant, what would it be? Well, we know that the entire thing for the third quadrant is, well, there's a couple ways of doing it. But to find the reference angle here, we know 180 is half. And then the remaining would be this phi, this angle that we're trying to find right here. So how would I find the measure of phi, which they call theta prime? I would do the angle, theta, minus the 180 degrees, or the angle theta minus pi. Likewise, in the third quadrant, if I looked over here, think about a triangle dropped right there. We know the entire thing is 360 degrees. So if I want to find this angle phi right here, to find that angle phi, I would do 360 degrees minus theta would give me the angle of phi, which is the same thing as 2 pi minus theta. So that's what they're doing right there, is they're saying, how do you find the reference angle? So instead of finding like cosine of theta, because theta is too big of an angle here, you would find the cosine of phi instead. How do you find the cosine of phi? Well, or how do you find phi? Those are the different formulas. Are you going to be using this? No, you're going to be using your dang calculator, but that's how reference angles were formed. That's when you know whether things are positive or negative. It is going to come into play later in Calc 1. It most certainly will come into play in Calc 2, that you memorize these types of things.